guys, nobody is expected to fail the GA. Only in extreme cases where you must fail. Like we're saying here, you say we are developing this. In other words, we are giving you these techniques, we are giving you these skills. So we'll check how much you gained that. If not, then we must give you a second chance at that chance until you have acquired sufficient knowledge and sufficient skills to perform this task. So do not take it as a form of punishment or as a form of failing you. Up to now, good people, nobody has failed this development stage in our subject, if I remember well. So what I did then, I removed this part from the assessment of the PREC. We'll explain more about the assessment of the PREC, guys, next week. So we assess this as a separate component, then we attach it with the PREC. But when you do the PREC, you've already passed the GA, you just have to pass the PREC. So for us, there is no gray area about that. Everybody is expected to pass the GA. Only in extreme cases where a person may not pass the GA. So this statement, guys, is about something that we observe every day and something that we live with. If we haven't seen this, guys, you can go to anybody that has a motor car and try to observe it, especially the latest models. The statement says a car manufacturer wants to improve the interlocking system. So it means there is already an interlocking system in a car, but wants to improve such that if the driver is not seated and if the clutch pedal is not pressed, the engine does not run. So the objective here is that you cannot stand outside the car and put the hand through the window and start the engine. That is a preventive measure or protection, safety. Why as a driver's seat? Somebody must drive a car, and to drive the car, you must be seated. That is what this specification requires. Why the clutch? When the engine starts running, if the clutch is engaged, then the car can start moving and you can cause an accident. So it's for those that can drive. It's advisable that when you park the car, you put it on gear number 1. And when you start the car, you first put it on neutral. But many times people forget to put on neutral and just turn on the key and the car starts running and you can cause an accident. So the aim of this task then is to prevent that. For the engine to start, the driver must be seated and the clutch pedal must be pressed. Then the statement goes on and say, there is an LED that will indicate that the system is ready. That means when you turn on the key before you start the engine, an LED will come up to show that the clutch is pressed and there is somebody seated. Then you can turn on the key. Then it says when the engine is running, this LED will go off. So that is what is required. You press the clutch, you sit on the chair, and then the LED comes on that the engine is ready to start. When you start the engine, then this LED goes off. Then the specification goes further and say, because the car uses a 12-volt battery, you must use now a 12-volt motor. So you need to simulate this system. There must be a motor that must turn, but we'll use a 12-volt motor. Remember in class when we were discussing the motor, we said a 5 volts you can drive direct from the microcontroller, but you cannot drive a 12-volt device from a microcontroller because it's a 5 volt system and it supplies a maximum of 25 milliamperes. That is too small. Then you need to work on the system then of driving your motor, either using a transistor or using a a relay. But this is not a punishment, guys. Where you get stuck, we can guide you as long as you do it before the dates that are stipulated below. Then it says the digital sensors. Here we talk about digital sensors because when you sit on the car, when the driver sits on the driver's seat, there is a switch that will indicate that there's somebody seated. That's a digital. If you stand up or move away from the switch, it will indicate that there's nobody. It must switch off. Also, when you press the clutch pedal, a sensor will switch on. When you release it, it will switch off. So those sensors then can be simulated using the push button switches. So we say that because these sensors are all digital, they may be simulated using the push button switches. We started the switch with you guys previously, and you know how to read the switch. Then what is the task here? Your task is to develop this system. When you develop the system, you must take into consideration the steps that are discussed in theory. Which are those steps now? These are the steps that are indicated above for the design. We'll go over those steps quickly. Before we look at those steps, guys, do you understand what you are expected to do? That is the aim of this task, to explain to you what you are expected to do. Do we all understand what we are expected to do? Kuluman Pala,
No,
do we
sir.
all understand what we are expected to do in this task?
No,
No.
No, sir.
No.
Yes, no.
Yes.
No. No, sir, no.
No.
Okay, this is what you are supposed to do. Let's look at this task that I'm showing you on the student task. At the bottom of the last sentence on the student task, it says, develop the system, taking into consideration the steps discussed in theory. Which steps are those? Is the design process that we will discuss just now. What you are expected here, guys, is to develop a system. What is this system doing? This system is an interlocking system. Firstly, a clutch must be pressed, and there must be somebody on the seat. When a clutch is pressed, somebody on the seat, the LED comes on to show that the system is ready. Then you start the engine. When you start the engine, then the LED will go off and the engine will run. So basically is what I demonstrated to you in our last online class, or what we were doing it in class, where there's a motor and the LED. So when the motor is running, the LED goes off. When the LED is on, the motor is off, and so on. But here we've got two sensors. We said we'll use switches to represent centers. So here is your schematic with the two switches, one representing a seat sensor, somebody seated on the sensor, one representing a clutch pedal. Then we'll have two output. One is a motor and the other one is LED. But what is required here is that the motor is 12 volts, then you must interface it accordingly. That is on the design side. Then in the program now, you check that both switches are closed. That means now there must be another switch then for starting the motor. These two must be closed. When these two are closed, then you must turn on the switch now to start the motor. When the motor starts running, the LED must go off. That is the simplest task that you have to do. But what is required is that you must follow the steps when doing it. Okay? Bezwakala lokho. Well, let me give you the chance just on what I've explained to you now. Yini eyinkinga? What is the problem? Kulokho esengikuchazele up to now.
Teacher. Ukubuza uthi kuzoba nama-switch awu-3.
Now, if we look at the statement, Miss, this is our statement. It says there is there's somebody must be seated. There must be a sensor that senses that you are seated. And a clutch pedal must be pressed. There must be a sensor that shows that a clutch is pressed. So there are two sensors. So when these sensors are activated, then the engine can run. It means now there must be a switch for running the engine. But this switch, for it to function, it depends on the other two. The other two must be closed. So there are two switches that represent the sensors, and there is a switch that represents the start or the ignition system of your car. For you guys to understand this, you must go to any car and try to observe what we are talking about. So there are three things on the input side. Is a seat sensor, a clutch pedal sensor, and the ignition for starting the engine to run. Then on the output side, we've got the LED that shows that the system is ready when the two switch sensors are closed. Then when the motor is running, the LED goes off and the motor starts running. Basically, that is what you have to do. Then you say, develop the system now, taking into consideration the steps. We are going to discuss the steps now. So we are developing a system here. What is in the system? There is a seat sensor, there's a clutch pedal sensor, and there's an ignition on the input side. On the output, there is a motor and there is an LED. When the seat sensor and the clutch sensor are activated, the LED comes on. When the LED is on, then the ignition can start the motor running. That means if these two sensors are off, the LED must be off. So these two sensors for the seat and for the clutch must be on. Then the LED will come on to show that the system is ready. When the LED is on, only then can the ignition start the motor running. When the motor is running, the LED goes off. Okay, and how are you going to do this? You need to develop the system and need to write the report and submit the report for marking. But the condition for me to mark is that you must have demonstrated this functionality, because this it means you must simulate. You simulate, you can do the simulation in the lab, you can do it in the laptop, but I must see this before you submit. When you have Monday, from Monday 9 May to Friday 13 May, please do not wait for the last day. You can start submitting anytime, even in not tomorrow, I will not be around. Even on Tuesday, you can come to demonstrate, just to show me that you have done it. So I will print a class list, and on that list, every time you come to demonstrate, I will put a tick. So your demonstration does not have to be 100%. You can show me what you have done, then go and fine-tune it. And also when you demonstrate, I can give you guidelines here and then say, well, you can try this, you can try that, and so on. But you will we are expected to submit this on Monday, the 16th of May. But for me to mark, guys, after you submitted, for me to mark, I will open the script, then check on the list that you did do the demonstration. If you didn't do the demonstration, I'm telling you now, I will not mark your work. And the guys here, we do not penalize people. Some say, oh, you can deduct marks. I'm not deducting marks from anybody. But all that I want for people, because here we wanted to test that you acquired the skill. Which skill are we showing you? Is to design and to simulate. In GA3 we design, in GA5 we simulate. I want to see that you can design, and I want to see that you can simulate. So guys, please, this is critical. As soon as you have finished, then you can come show me. You can come with your laptop, or you can go to the lab when you're ready, then you call me, I'll come and have a look. Any time between this day, Monday the 9th to Friday the 10th. If I'm not in class, I'll be available to come and view. Guys, this is outside the learning time and outside the practical time. We won't use the prac time for this. We'll use the prac time to assess the practical component that will be discussed in the near future. So this, we are solely responsible, is your task. You must make sure that you demonstrate before you submit. And I gave you the whole week to do that submission. And I gave you this 4 or 3 weeks before that time. So nobody can say it did not have enough time. My request to you is that you do not wait for the last day. I may not be able to handle all of you if you all choose to come on Friday the 10th. Sezwan?
Yes, sir.
Yeah.
Yeah.
Ogunyege, before we go to the theory, they said there is a theory. Before we go to the theory, guys, allow me to open just one lesson. Let's say I will open the lesson 2, for example. Not that we want to do the lesson. I just want to show you something. I'm giving you a hint of what will be expected in this design. Okay, let me unshare this document. We'll come back to this document, guys, because I still have to explain the design process. Okay, you can go through. Can we all see this document that I'm sharing now? This is lesson 2. But you can check in lesson 1, you can check in lesson 3, you can check in all the other lessons. What I want to show you guys, and also you can check in the books that we use. So you must differentiate between design and simulation. That is what you are tested on here. You are doing design, the GAs that you must be able to design. If we design, good people, we follow the rules. One of the rules that we have is that the microcontroller is the controlling part of your digital system. And we indicate the master clear and we indicate the code. This microcontroller, this one, the 18F458, has got 40 pins. But when we design, we do not show all the 40 pins. We only show the pins that we are going to use. So if there was input, we are going to, another thing is that we first start by connecting the master clear to 5 volts via a 10K resistor. Then we indicate the inputs on the left and we indicate the outputs on the right. And my advice to you guys, only show the pins that you are going to use and label all the pins that we are using. Indicate where that pin is connected. We have got 34 I/O pins. You can use any of those pins in your design. I don't expect all of you to use the same pins. You can use any of those 34 pins. Just recall that if you use port A, you must switch off the analog to digital converter. And if you use port D, you must switch off the comparator. We showed you that in the lab using the CM-con register and the AD-con registers. Remember to do that if we are going to use any of those pins. So guys, I wanted to advise you that please do not write anything inside this rectangle and do not show all the pins that that are in the microcontroller. only show the pins that you are using. Okay, let me unshare this and then go back to the design process. I'm going to share the design process now, guys. It is still on lesson 3. We are about to come to the end, then I'll give you guys a chance to ask questions if you have any. But I will be available for you guys until you submit, until the last day. This is what is expected from you then, guys. Now, in your report now, you must define the problem. This is the design process now. These are the steps that are listed in GA3 and in GA5. When you design, remember what I said to you in class, and I've always been saying this. We do not just sit and design. Just like a program, we do not just sit and write the program. We design in order to solve a particular problem or to obey the given instruction. That means here, you must define the problem that you want to solve and give the specification of how we are going to solve. Like I gave you the specification in the statement that there is a driver's seat sensor, and there is a clutch pedal sensor, and there is the ignition sensor, and there is a motor, and there is an LED. That is your specification. So from that given information, then you must define the problem that you are going to solve. This is now the write-up, the report that you are doing. Then you find the related information. Most of what is required here, guys, is what I've been telling you. Then specify what you are going to require. Then develop with the schematic, like I've just shown you that one on lesson 2. I want you to follow that procedure. Then you do the simulation. We do the simulation for us. Then, guys, we use Proteus to simulate. And this is what you have to demonstrate. After we have done that, I said here, the simulation should be demonstrated in the lab to verify the student activity. The aim of this demonstration is to show that, yes, you can do this. At the end, I want to say, yes, you acquired this GA. So I want to see you doing it. Then after that, then you write the report. Then you discuss the results of the simulation. So what am I going to do now to give the marks? This, guys, is what comes from that GA document, what I indicated to you there as the what you call the prerequisites on that GA document. So you formulate the problem, you plan the design process, and so on and so on. This is directly from the GA. Guys, I wanted to go over this with you before you get started so that you are not left in the dark. So, is there anybody that has a problem? This is what I wanted to cover with you. Is there anybody that has a problem with the task that you are expected to do, good people? Any question, any comment, any suggestion? Okay, guys, allow me then to stop the recording. I'm stopping the recording now.
Are you done?
Okay, let me stop the recording. Okay, good people. Ilokhu-ke ebengifuna ukukuchaza kunina namhlanje. Ukhona onenkinga nonembuzo nje nofisa ukukuphawula kule discussion ethu namhla.
Tisha, sacela usiphinde usihighlight lela lento esimele siyenze la.
So sorry Ntando.
Sacela tisha usiphinde usihighlight lela lento ama-LED nemoto ukuthi kwenzakalani ngigcina ngasazwanga kahle.
No. A statement said, let me put this statement back. Iyona le evolution. Nasi statement said to la. This is what we are doing. This is what we are doing here. It says develop a system, but in your developing your system, you must take into consideration the step discussed in theory. Those are the steps that are indicated above here, what I was showing you. But what you are doing here, it says a car manufacturer wants to improve the interlocking system. It means this system is already there in the car, but you want to improve, we are upgrading. What must happen now is that for the engine to run, a driver must be seated and the clutch pedal must be pressed. And there must be an LED that indicates that a driver is seated and a clutch is pressed. Only can the ignition turn for the engine start. When the engine starts running, then the LED will turn off. So this doesn't tell you what happens after the engine has been running. You are only interested in that part. The rest is your own innovation and imagination. So what you are required here, guys, what is expected from you is to design a digital system that consists of a driver seat sensor, a clutch pedal sensor, and the ignition system. And there is a 12-volt motor that indicates the engine of the car, and the LED that shows that the system is ready. But when the engine is running, the LED turns off. That means when the engine stops, the LED will come on. This is basically what we have done, actually, guys. I even gave you the program for this. Yours is just to modify that program.
I would clear, man.
But what is important is that you must demonstrate the functionality within the time that is given there. I gave you 9 to 13, but you can come any time before the 9th. As soon as you are finished, so that you get done with this, you can come and demonstrate. All I want is that you show me that there it's working, you develop it, then I just put a tick. Well, that tick has got additional mark in your document, because I'll add marks for demonstration also. But that does not mean that if you did not demonstrate, I will deduct marks. No, demonstration is mandatory, it's compulsory.
Okay, sir.
Yes, miss.
Kushuthi ngomhla ka-9 to 13 sizobe sidemonstrate kuphela, and then i-report izobe silandela emva kwalokho.
According to this statement here, it says the final submission day is Monday the 16th. The
Okay,
report
sir.
is expected on Monday 16th, final day. So it means after demonstration, as soon as you demonstrate, when you finish your report, you can submit. But the closing date for submission is Monday the 16th.
Okay, sir.
Yeah. Guys, thank you for the probing questions and the comments that you are making. Is there anybody that still has any question about this? Before we close, then, good people, we had a discussion with Mr. Mngomezulu. We were affected by the disaster that we are all aware of. And the week 2 students have been affected mostly. It's them that were affected adversely, and they are far behind. We request then that next week, both for theory and for the prac, in the day group, we have week 2 for theory and for the prac. Also in the evening group, that does not count in theory, is for the prac. In the evening group, though we saw that group yesterday, we did not see the others because we were disturbed. So we request that next week, guys, we continue with the week 2, both the day and evening in pracs. Then in theory, week 2 day. Then evening will continue as we normally do with evening in theory. CS1?
Yebo, sir.
Okay.
Yes, sir.
Good people, ilokho bengifuna ukusho kunina inembuzo nikhulele ningabuza kodwa sesiqedile. Thank you for your time and this is a sacrifice on your part. So for next week then, guys, we will do lesson 9. I did explain to you that lesson 6, 7, and 8 will not be covered with you because we will do lesson 12A with you. I also noticed that in lesson 11, I duplicated lesson 10, but we are not going to correct that. So we'll do lesson 9, 10, and 12A. We'll sort that out with the others. So I've got 3 lessons left for you before we write the examination. So to prepare for the class then next week, guys, go over lesson 9 to be ready. Eh? And thank you for your time. Go and enjoy the rest of the evening. Bye-bye.
Thank you, sir.
Sir,
Thank you.
Yes, it's Tembiso.
Sir, bengicela ukukhuluma la mhlambe noma personal before ngoba baqala ukuphumela lapho siyakhuluma not the nesikole.
Now maybe for that ungangithinta ku WhatsApp ke ukuze ngoba
Indawo.
asakhana bangepho ungangithinta ku WhatsApp.
Asindawo.
Ngaba indawo so ngithinta ku WhatsApp for that.
Ukuzwa.
sicela ukubuza.
Ufuna ukuzwa nathi.
Okay.
Ngisacela ukubuza le class leli uzos-uploadela lona ku Blackboard.
Oh yeah, I've recorded this 5 minutes after the recording it will be available, then I will upload it.
Right, sir. Thank you.
Sorry, sir.
Yes.
Imoto ikhona component ethi imoto iprocess
Sorry.
imoto sir ukuthi ikhona component ethi imoto ku-process.
Oh yes. Everything that you talk about is there in Proteus. But guys, my advice to you, choose the animated components that can function. Eh? For the motor, also take the animated one. You can see it turning. Yes, it's there. Okay, guys, good evening then. Remember, I'm still there for you. If you get stuck, you can always contact